Hello everyone, my name is Xiaowei Sun, and today I will talk about introduce our review of the linear algebra with Sage. And mainly we are talking about those links were written here, and the main website is this one, and others related links are like as following. And here's those links, and mainly we are considered this website, and from chapter 1 to chapter 10 already professor gives in detail, and for each chapters you can go inside the links, then you can find the detailed concept and the related problems. And also here's some matrix theory, and here's other kind of written in Korean and about the linear algebra. And here's many definitions about the linear algebra, and also written in Korean and English. And also here's a big book exercises of linear algebra, and here also the similar means English version of the big book. And since there's many concepts of the linear algebra, today we will just focus on the first 4 chapters and some of important concepts for last 4 chapters, such like power method and linear transformations and rank nullity theorem and diagonalization and Jordan mechanical form and so on. So first we will consider about the chapter 1 vectors. Actually, for this chapter we are talking about the vectors in n spaces, and mainly things about the interproduct and of 2 vectors and norm of the vectors. So here we give in some small examples. For example, here is a link for how to get the norm of the vectors, and means for given 2 vectors, how about the norm of x, y, and x minus y. So here we just put answers. For example, here we put 1, 20, 25. Then click these numbers, then we can see our answer is wrong, and here's the right answer, and with the process. And also for related the definition of the norms, and here is some examples you can try and hear. So this is for conceptor, means in order to find the answers we just put here. Vectors means x we can put as a, and b, y we can put as b, then we can easily get related answers, then we can put the answer here. So this is a way to using computer tool, means Sage. Here we use to do some exercise with linear algebra. And the others is about find the equations of the plane. So for given point and normal vectors, we can find the coefficients of x, y, z, and also d. So here we can just put answers, then we can check our answer is right or not. And also if you refresh the page, so again the same kind of problem, but the exactly values are changed. So this kind of system we can generalize the same kind of problems by randomly. So it's a good way for students to check themselves is know this concept or not. And next one is the linear system of equations, and mainly things are the Gaussian animations and the Gaussian-Jordan animations. So here also we're checking from this link we can fully understand how it works. First, they're giving the definitions, means how to do the Gaussian method And first we have to find the REF of A, and then we find REF of A. And also here's a small examples. We can use Sage to do it. You can see here's a code for get answer from this one. And next we can exactly do some exercise to check our knows or not. So next one is chapter 3 about matrix and matrix algebra. And here for 3.1 there's matrix operations, and first is about just minus, plus, and the scalar product. And also here there's some definitions, and here also some examples, and with giving code to solve the answer. Now here is one means random problems, and we can try and to find we are get the idea or not. And also here is about another operations, means scalar of 2a minus 5b, means some scalar product with two matrices and some operations between them. Again, there's some definition and computer exercise. Then we can this kind of questions again means similar kind of things. If we refresh the page, then also the value will be changed by randomly. And here is a multi-product two matrix, like this way. And another one is the inverse of matrix. And here's the definitions, means where we of this inverse matrix. And here's some related problems, and here's some computer examples. And here, so we just to confirm this one is inversible or not. If we choose yes, what's exactly values? For example, we put like this way, then we are wrong, and this is the right answer is like this way. And if we choose no, then also the answer is wrong, and the right answer will give him by belong. And here is by RREF of ARA. This method we can also check the A is inverse or not. Yeah, we can check like this way. Means here showing the process how we can get the if the matrix inverse, then how we can get the inverse matrix by this way. And here showing the detailed process how we get it. And next important things is some special matrix in the linear algebra. For example, first one is about the symmetric matrix and skew symmetric matrix. And here's the definition. If symmetric matrix, then A transpose equal to A, and skew symmetric matrix A transpose equal to minus A. So here, for giving one matrix, we have to confirm one of them. So surely here for this matrix, easily we can say this is symmetric, right? So our answer is correct. If you choose another one, incorrect. So if we again refresh, then we can see this is means A transpose equal to minus A. So it should be no. So it's either symmetric because this one not equal, and also not this one because here 4, here also 4, should be minus 4 but 4, so none of above. So our answer is incorrect. And also here's some orthogonal matrix. So here definition. So definition, we can say if A inverse equal to A transpose, then we can say this is orthogonal matrix. And if you click question, then this will be a new randomly different one will becomes, right? So we can say if yes, then incorrect, because if from the definition we can say in transpose product A inverse should be identity matrix, but here surely not. That's why the answer should be no, right? And LU decompositions we can check by following website which I made published in Mastery servers. And here for given A, and we use A point LU, then we can easily get P LU matrix. It's an easy way to use SageCalc to make LU decompositions. And here also one useful tools is developed by Professor Lee. And here's means for any 2x2 matrix, we can take some operation between two matrices, and also we can say rank and null and determine and many other things. We can eigenvalues and LU, QR, all these things we can check here. And also we can confirm a square or not symmetric, inverse table, and permutation and unitary, all these kind of things. And so I think this is very useful tools for us to check the matrix. And here chapter 4 is about determine. So again, there's one kind of means first what's the definition of the determined, and here also we have the this kind of questions, and we can, if you press the questions, we can refresh one and do it again and update. Then it will be wrong, and the answer will be given by this way. And next is important concept is about eigenvalues. So here also eigenvalue, definition of the eigenvalue and eigenvectors. And the following is about the, for given one matrix we have to find the eigenvalues, because it's 3 by 3, so we have 3 eigenvalues. And for example, we do like this. Oh, we are did wrong, and here eigenvalue should be like this way. And if we click the question again, then the problem will change. And here is the diagonal, so we can easily check -5, 8, 9. Okay, then oh, yeah, it should be -9. That will be correct. But also here, if you change the range, also it should be right. Yeah, you can check, always be right. Either you. And next is about the permutations. So even permutation and odd permutations, such a definition, and for given set determines the permutation is even or not. So like okay, or should be odd because this should be in set. So it's exactly 3, and this permutation should be odd. So if odd, we can correct. Again, if you press this one, you can see change always, every time it will change. And next about the adjoint matrix, and adjoint matrix defined by this way. So for finding some matrix, here gives answer and how the right answers it is. And the last one is characteristic polynomials of the matrix. And here also there's one definitions, and yeah, because it's related to the eigenvalue and eigenvectors, so also here's a definition of the eigenvalue and eigenvectors. So here was a 3×3 matrix. We have characteristic polynomials, it means maximum powers is 3. So we only have to gain 4 coefficients, then we can get an idea of the polynomials. So here is wrong. So how to get it? Let's show the process. Since time is almost finished, so I will not go more inside for following 4 chapters, but it's very easy to it's very useful to use Sage to get this kind of concept and understand fully. And here's our conclusions. And there's many basic concepts of the linear algebra, and using computer tools helps us understand these concepts much more easy. And it makes different from others, and it will be helpful for students who want to go more inside in this subject. And what's more, Sage can be used to generate the problems of the linear algebra randomly, and it can be help us to check ourselves how much we understand in this concept. And this is end of my presentation. Thank you very much.